use Google logins, don't use session. Use Gorilla sessions with manual routing, like I showed. You have to create that serve mux, do it that way. Either via serve mux or some other router. Okay, so those are two options. We use Google or we do it ourselves. Or a third option, we can just do a regular cookie, store in that cookie a session ID, and use Memcache to store the session. Okay? And we will do that next. Okay? So, any questions about sessions? Okay, Memcache.
We haven't talked about Memcache yet?
Nope.
Okay, cool. Because I'm like,
what is Memcache?
When did we talk about that?
We didn't.
Oh, man.
So Memcache is a really cool program, and I think it was made for LiveJournal. If you guys remember LiveJournal? That was a long time ago. And that ancient history, they were part of the invention of the blog, when that became really cool, and everybody had a blog. And LiveJournal was one of these sites that let you have a free blog. But anyway, what they discovered when he was making these data centers or whatever, is that he had these servers that were running the app, and they were not using all the memory they had available. So suppose the server had a gig of RAM, and at the time that was a lot, and now it's like nothing. But, they had a gig of RAM, and their web server was, say, using 100 megs of RAM. And so they had 900 megs of RAM unused on a whole bunch of their machines. And so the idea of the program was, why don't we use that memory? It's sitting there unused. We're paying for it, right? We paid that cost for it. So why don't we use it? And so he created this program called Memcache. He ran it on every machine. And it would automatically utilize that RAM on all these machines. And the idea of Memcache is, it's a big map. So we talked about maps, right? You can get, set, delete, right? So you can put is like set, right? Same idea. It's a big map distributed across all your machines. And so when I sometimes it gets it from my local Memcache, sometimes it might go to another server and get it. All that you don't have to worry about. The point is that it's distributed across all the machines, and so I can use the RAM available on all these machines. So it's like a big distributed map, okay? And that's a really cool thing, because it means I can cache, like if I have a database query that's expensive, I can cache the results in Memcache, it'll be very fast. Because it's essentially an in-memory lookup, so it's just as fast as doing a map. So that's much faster than going to a database and querying. And so that's a great feature to have a system like this, to be able to store things in memory. So the important thing about Memcache is it's not a permanent data store. It's not like a database, because the data in it can be erased. Just like when we have an in-memory, like if I write to a map, restart my program, everything I wrote to it's gone, right? It always starts from scratch. And Memcache is similar. So we use it to store cache things that if it's not in there, we can get. So is it in the cache? Great, serve that to user. If it's not, I'll just do the query, get it from the database, then put it in the cache, and then give it back to the user. And so, in other words, most of the time, say 95% of the time, I get it from the cache. And 5% of the time, I have to get it from the database. By doing that, I've significantly decreased the load on my database, which improves performance. So we use it as a cache sometimes. The other thing it's great at is something like sessions. Because if I lose a session, no big deal, user relogs in, it doesn't matter. But in general, if I can store their data inside of this Memcache, right, that means every time they come back to my page, I can just get it out of Memcache. So instead of having to store it in their cookie, I can store it in Memcache. Everybody follow me? Why don't we use Memcache and not a map? Because I could just store it in a map. Why don't I do that?
Well, a map is part of your running with your program.
Yeah.
That is more. I mean, it's kind of like more connected to your program, and Memcache is a sort of a storage component removed from your program.
Yeah. So I have, if I draw a box here for the server, I could have a map in here, and I could call it sessions. Map. String. And I'd have some ID, 1, 2, 3, 4, whatever. And I'd store in here is, a test of example.com. So I'm storing their session ID to their email, for example. I could do that. The problem with this is I don't just run one server. I have lots of servers, right? And actually what's happening is in front of these servers is my load balancer. And so he's sending it to different servers. So the first request may go to this one, and the second request may go to this one. So you see the problem now?
Yeah.
This data only exists on this server. So I get to this server, he's not logged in, because he's not in my map of sessions, okay? So the point is we've created another server over here. And instead of going from here, so we don't do that, we go to here. And now they can all reach the same. So now the sessions are in here, okay? That's why we use Memcache.
Now, with the way that would work, Memcache is then sort of saying, I'm storing all this stuff, and I have these things stored, and I have to go get this one thing, and it's using a piece of memory on that bottom server, and go get it from that server, bring it back to Memcache, and then send it to the server that asked for it.
Yeah, so that's the funny thing is it's an abstraction.
Yeah.
So to us it looks like this. In reality, Memcached is, actually on all these servers.
Yeah.
So, but we don't have to worry about that. That's not our problem, that's Google's problem to deal with. We just have to use the API to get it. And wherever it gets it from, whatever. It might be on one of the machines, it might be on a different machine, whatever. It doesn't matter. It's just any of the servers can get it, that's the point. Okay? So that's why we use Memcache for caching and for things like sessions where if we lose the data, it's not a big deal. So the API is really easy. So I'll create a new Memcache example. We basically use it just like a map. So create a Memcache example. Let me copy this. Okay, so I have my blank page. I want to get a context, because remember I told you that pretty much all the things we do with App Engine, we use a context. So I'm going to get a context, and then if we go to the docs for Memcache, so let me get rid of these guys. Memcache, and then reference. So remember I said you could use either this or the other one. So if we look at the other one, I guess I'm better off looking for App Engine. Memcache is a general product. It's not an App Engine specific thing. So lots of people use Memcache, very popular product. But they have one for you in App Engine. So probably have to go get that. I always think that's funny. It's like, oh, I'm gonna have to go get that. Like literally go get that. So let's see. And so we can just do get this C as the context and then the key. So I say, value equal memcache dot get the context and the key. So sum dash key. So that looks just like, you should recognize this as value equal map. Let's call it my map. That's some key, right? Same exact idea. Following that? So we use it very similar to a map. The difference is this actually returns two things. But so does a map access, right? It can return a true or false if it's actually in there. And so this can return an error. This can fail for other reasons, like it's unable to connect to Memcache and stuff. Like I said, Memcache is volatile. It's not something you can trust to always be there. And so you should build your system such that if it's not there, it's okay. If you need something to absolutely be there, that's when you use a real database. But if you're just using it for caching, you're okay if it's not there. And so you should treat it as, well, it's probably there, but maybe it's not. But then you check the error to see whether it was in there or not. But we can ignore the error. What will value be if it either is not in there already or fails? You guys remember?
No.
Well, it's a string, so it'll be the empty string. So sometimes that's good enough, right? I can just check for the empty string, and that'll cover all the cases and the errors and everything. Okay. Where's just get? And so we can do set and similar. So let's look at the examples I have in there. Oh, I'm sorry, it's not a string, it's the item. So it'd be the item dot value. There it is. So we'll just print this out. So Memcache example, go out surf. No. So you're right, it was no. That's because it's an item, not a string. But if it was there, then it would be item.value, and then that would have it inside of it. So you could say. So if we want to set it, we use Memcache set. And the reason why it's an item is because it has its support for expiring. So I'll show you that. But you can create it this way. So the key here is going to be some dash key. The value, we can name it anything, right? What am I going to get from this? What do we expect this to show?
The string?
Yeah.
Some value.
Some value. Okay. Let's see what happens. So everybody following that? For Memcache, we use set to set it and get to get it. So it's just like a null. That in general is how we're going to use it. It also has add. The way add works is it sets it if it wasn't in there already. If it was in there, it can return an error. So add's an interesting thing that allows us to see whether it was in there or not. It's a good way to check to see who's already in there. But we usually just use get and set. And like I said, it supports expiration. So
Wait, so what's the difference between getting set? I mean set and add, sorry.
So add adds it if it's not already there. If it is already there, it returns an error and tells you it was already there, which you could use for locking. So say you had you're selling tickets on your website or something, and you want somebody to be able to hold on to it while they're purchasing it so nobody else can buy it. You might use Memcache to do that. Okay. Let's see what item was. Here it is. We can tell expiration. So let's add that. Let's do 10 seconds. So it works with the time library. So we work with time before, right? It's just time.second is a duration. So we say 10 seconds. So this will expire after 10 seconds. That's what we're trying to do. So let me hit it. Okay, yeah. So some value, and then I'm going to comment this out. So it's no longer setting it, we're just getting it. This works, but after 10 seconds it should stop working. There. Make sense? So after 10 seconds it removed it. So we can store things for a period of time, and then after a while they go away. That's super useful too, right? Being able to store things for a small amount of time. So, for example, that makes it possible, like I said, we use this as a cache, so we can cache the results of queries. We can set a duration. So, oh, I only want to store this for a minute, and then I want to get the new version. You can easily do that with an expiration. You set the expiration to a minute, after a minute, it gets removed from the cache, and then you can report it. Okay? So that's the other way we use Memcache. And then finally, you can use it as a counter. So in here, there's an increment. So where's increment? Increment. Let's look at it in docs because it's easier. So give it a key and a delta, an initial value, and it will increment it. So why do we need a separate increment? Because we could just do a get, change it, and then a set. So why do we need an increment? This word. Okay, so here's the reason why. I have two servers. So we have S1 and S2. And they're both writing to the Memcache, so we'll just call this M. And he does a get, and then he does add one, and then he does a set. And he does the same thing.
Went up by 1 instead of 2.
Yeah, that can totally happen, because the order of the operations may be S1 get, S2 get, then S1 add, S1 set, S2 add, S2 set. So this may be the order they happen in. And so what we end up with, if it started at 0, then it gets set here to 1. But remember the add here is, this is 0 right here. So then it gets set to 1. So instead of 2, we got 1. Right? What we need is for these gets and sets to happen atomically. They need to happen all together. Right? The get, the add, and the set all happen as one unit. That way we can have all the S1 get and sets as one thing, and then all the S2s. Okay.
That takes care of all that complicated logic.
That's right. We just call it increment. He does it for us, and we're great. And that's why you need an increment, is because once you get these distributed systems, you end up with this complicated, the order of the operations can all be different. So if you need a counter, you use increment, and you're good to go. Okay? So the example, the problem we're going to do, really easy. Use Memcache to implement a counter every time a user visits the page and show that value of the counter. So you remember in the earliest web pages, you go to a site and at the bottom it had your visitor number, 1 million. We're doing that. We're building that with Memcache. And then the second problem is make it per user. So I want to have that global counter every visit, and then right below it, how many times that user has been to that site. Okay? So let's work on those.